You're recording.
Okay, so apologies to everyone. We had some technical difficulties that we have hopefully overcome. But relax. We're going to have Dr. Chelliah go through with the talk as intended, and hope everyone can join in. So let me introduce just briefly here. So today's first, welcome to the Virtual Lab Forum. And I remind everyone that the purpose of these forums are to have different researchers, developers throughout NOAA's universe present and inform us of things that could be transitioning to weather service operations in the short term, medium term, and long term, even climate scale, I suppose. The format is we have a presenter give us an overview of their topic, and then we have some question and answer that follows that. The session is recorded and will be uploaded to the website after the presentation. So today's topic is entitled Towards Closing the Gap in NOAA's Seamless Suite of Forecast Products, Prospects for Useful Predictions for Weeks 3 and 4. And it's being presented by Dr. Muthuvel Chelliah of the Climate Prediction Center of NCEP in the National Weather Service. So without further ado, I'll hand it over to Dr. Chelliah, and I'll advance the slides for you. Okay. Let me make sure that you'll want to be near the mic as possible so the audience can hear.
Okay.
So go ahead.
Okay. Thank you so much. Thanks for coming, and I apologize for the technical difficulties we had, and hopefully we should be able to move through right along.
Can we check that the people on the phone can see that we're on the title slide and not on, I'm not sure if
Can you all see the title slide? It's a white slide with blue text. I think so. John took us to me. So
no, Steve, we cannot.
Cannot?
They're seeing a slide with the maps on it, some model output of some sort.
We can do that.
Well, I think what happened is the GoToMeeting is prompting me for confirming that I want to transfer control, but I can't see that screen, and so I can't click yes. I'm going to go ahead and hit return and see if that does it. So hold on just a second.
I'm not even sure why that's even coming up, where that's coming from.
Yeah, I don't know.
That's probably what's being displayed in the conference room. So in the large room, John is the presenter, and your presentation is on this middle slide. And we have not successfully been made the presenter.
It looks like I can quit it. Oh, wait a minute.
That was, all right, so John's going to try to make his screen visible. Usually it's not bad at all.
I can seem to see. It looks like it allows me to click this, but then.
But then you'll exit the go-to website.
Oh,
so we're not.
Can I push that? Oh. Keep going, John. You're going. Is it going forward or backwards?
Going forward.
John, you're going forward. We see the slides. Can you go back to the, hit the back arrow?
Were you talking? Yes. Okay.
He's going forward. That's 15.
Yeah.
Steve, are we at the title slide yet?
Oh, you're going further out. You're at 25. Yeah, now you're going in the right direction.
Tell us when.
Keep going. You're at 15. Keep going.
Keep going.
There. Almost. Keep going.
Just go until he tells us to stop, I guess.
Yeah.
9, 8, 7, 4. Keep going, like 2 more. Next. There you are. Oh no, one more. Keep going. Okay, we're there. All right. Okay.
Are we going to control the talk from
Yeah.
there?
John, you're going to have to advance the slides for us from there. All right.
All right, we'll do.
Okay.
Okay. Can you hear me? If I ask you to move to the next slide, can you please do that?
Yes.
Okay. Okay. I'm not sure how this is all going to go through, but we will try it anyway. We have an audience here, so they're staying here. So, so as I said, this talk is going to be pretty straightforward based on some relatively very simple calculations and hopefully with some practical implications for week 3 and 4. Next slide, hit enter please. So originally I thought of giving the title to the talk as Thinking Outside the Box, and you will understand why next as we move along. Next. The motivation for this talk came from this coach, and as you can see from here, I think as I will explain in the next 2 slides, we have to have the users in mind all the time as to what their needs are before we develop any product and so on. So next one, please. So this is the NOAA's seamless suite of forecast products. And next. So right now there are no official forecasts, even some sort of guidance for weeks 3 and 4. We have some kind of a guidance on all time scales, starting from nowcasting minutes, hours, days, up to week and 2 weeks. But then there is a gap, week 3 and 4, and then we start with some kind of a forecast product for months, seasons, and years. So this whole, or what I call as the forecast hole, is what I am trying to address here. Next. Next. Hello?
Yes.
Next.
I hit it 3 times.
Oh,
Did it respond?
oh, response.
You know how Windows sometimes stops active?
Maybe we should reschedule the talk. Maybe I think this is. I don't know why we are doing this.
The taskbar is active, but not the PowerPoint window.
On this screen?
On this screen. I don't know how to bring up PowerPoint.
Oh, the cursor is somewhere. No.
Okay, so the taskbar, as you can see down here.
Mm-hmm. So you know how sometimes when you're in from the taskbar is active?
Okay, I just clicked on it. So now.
Okay. Looks like it's back on. So if you look at the daily weather forecast produced by the Weather Channel or the National Weather Service up to the next many days, next, you will see temperatures for tomorrow or the day after tomorrow and so on in terms of absolute numbers. Like, for example, this I took from yesterday's website, and now you have the next 2 days, many days. In fact, Weather Channel puts it up to day 10. And that is for temperatures or precipitation with so many inches of rain in absolute numbers. This is what we call it as weather. We don't say when you talk about tomorrow's weather, saying it's going to be 4 degrees cooler than climatology or some normal. We talk in terms of total numbers. Next. Even if you look at the quantitative precipitation forecast from the Weather Prediction Center, formerly the HDC, they actually talk about how much rain is going to rain in various places in so many inches. Next. But if you move to the beyond the next few days, if you look at the climate prediction centers, next 6 to 10 day mean forecast, or the week 8 to 14, this is the CPC website, you will see that they immediately convert to probabilities. They immediately talk about temperatures being below normal or above normal with respect to some reference to climatology, with respect to some normal period. And so the forecasts are issued in terms of some probability. We immediately convert from total field to anomaly. Next. So this is the typical examples of how CPC forecasts look like. And the top one is for days 6 to 10, and the bottom one is for week 2. On the left is the temperature, and the right is precipitation. It says from the various colors, it's going to be above and below, and they are above and below with respect to some climatology, some normal over many years. And people are supposed to kind of remember what those periods are. It's going to be colder than the last 30-year mean or 20-year mean or something. Next. So what's the dilemma here? So NWS started forecasts of 5-day means in the 1940s, and then they started issuing the forecast for 6 to 10 days, so the 8 to 14 days around 2000. Monthly means they have been doing it since the 70s, seasonal means since the 90s. Next. So why does the 3 to 4 weeks hole in the forecast continue to exist, or why have we not issued beginning today? What's the weather going to be like 3 weeks from now, 4 weeks from now? We cannot tell. Why have we not done that? Have not the models improved with time? What's the drawback? Next. So this is from a study in 1994, many years ago, and on the left is the anomaly correlation coefficient. That is the only measure I will be using in my talk, and this is for northern hemisphere. Northern hemisphere geopotential height. The x-axis is the days, and the y-axis is the correlation on the left figure. And you can see that by about day 10, the correlation is pretty useless, about 0.2 on the left. So the useful correlation is considered about 0.6 or something, or higher. So even this is an individual days, how the various forecasts compare to the observation. So this is how the state of the art was. So there is no point issuing forecasts in week 3 and 4, which is pretty useless. Of course, we know that we cannot issue a forecast on any given day. We only talk about forecasts averaged over week 3 and averaged over week 4. So this was the state of the art in '94. Next. So this is fast forward 14 years. This is 2008. This is from a paper by some people in Switzerland and then UK, Frederick Wittard and other people for the northern hemisphere tropics, extratropics from 20 north to the pole, southern extratropics, and the tropics. The top line in there is the correlation, is how the forecast score is for week 1, which is about 0.4, 0.5, and then week 2 and week 3 and week 4, where the red arrow is, and you will see the correlation is about 0.2 all throughout the year. And this is the state of the art in 2008. So it is as bad as, or it has not improved since before. So next. So this is from 2013. This is the stuff that I've been working on, and this is from the Climate Forecast System version 2, from runs from 1999 to 2010. We have about 10 or 12 years. And I did, okay, what is the correlation of week 3 and week 4 forecast? So if you look at the top, I just put in the other periods in there, like day 1, day 2, day 5, and week 1P means I call week 1 plus, because that's the day is 6 to 10. It's neither week 1 or neither week 2, so it's in between. So I put week 1P and week 2. And these are the two lines I want to pay attention to, week 3 and week 4. If you look at it, for 500 millibar heights for the globe as a whole, and for the United States in the bottom, we are talking about 0, close to 0 and 0.2. So this is in 2013. So we now, I think NWS has a mandate now to produce this week 3 and week 4 forecasts, because there is a missing hole in there, and if we start issuing forecasts based on the state of the art right now, we will be talking about a scale which is correlation of 0 or 0.1 or 0.2.
Who gave them the mandate?
Well, there is some kind of a requirement to make forecasts for me. No, just go ahead and make it. Okay, and this is where it is now. Okay, next. So this is for 2 meter temperature. That's for 500 millibar height. So something more familiar. Surface temperature, and week 3 and week 4 is about 0 and 0.2. There is some variation. Winter time seems a little bit higher, but most of the time it's between 0 and 0.2. This is for the bottom panel is for the temperature over the United States, a region near the United States. That's about the same thing, week 3 and week 4. We are doing okay when it's 1, 2 days, 1, 2, 3. But when you come to week 3, week 4, that's our period of interest. They are very low scale. Next. So this is the state of the art, as I said. And the next slide, please. So this is, again, the same thing for precipitation, for rainfall, and we are talking about very low scale. So we absolutely, if people will say, oh, this is 0.2 is better than 0, it is better than negative scale, we can talk all that, but you're not going to sell anything with that kind of a skill score to public and then expecting them to have some trust in the forecast. Next. Next one. So for the last 20 to 30 years, in spite of the vast improvement in our understanding and data assimilation techniques and modeling and so on, the predicted scale of anomalies in the week 3 to 4 range have remained stubbornly low. Next. So if you keep asking the same question, and if you keep getting the same answer you don't like for a long time, then it's time to start asking a question in a different way, or to start asking a different question at least. Next one. So we know at shorter time leads, up to 7 to 10 days or so, the future state of the atmosphere is sensitive mainly to the initial conditions of the atmosphere. Right now, in other words, what we observe today is going to decide or determine what the weather is going to be like next 4 days. So if you have a better, very good observation, you put them into your model, that's what it is. But when you go to monthly and seasonal time scale, next month or beyond, next season and something, it is not just the initial conditions, but it is related to something on a very large scale, like ocean temperatures, the ice content, and so on, which is called the boundary conditions, which is more important. Like El Nino. Now we know El Nino is coming. We know what kind of impact you are expected to see around the globe. But this 3 to 4 weeks is between this deterministic weather. When I mean deterministic weather means so tomorrow we can tell it's going to be 84 degrees or 85 degrees. Whereas when we move out to a season, we say, well, we have more or less this summer we can expect more precipitation than what we normally get, the kind of a probability. So this week 3 to 4, it's not weather, it's not climate, it's something in between. Next. So the metrics that we use to verify or to look at how the forecasts are for the week 3-4, it cannot be weather and it cannot be the climate. It's something in between. Okay, next. So to evaluate the week 3-4 predictions, we have always used anomaly correlation, like I showed in the CPC forecast, where the anomalies are computed as a departure from some climatology, okay, some long-term mean. And people are supposed to remember, are supposed to have that in the backdrop as they look at the forecast. Okay, but what is this long-term mean? Which is the mean over 50 years good? Is it mean over 30 years like the the WMO uses, or because this climate is changing, is it mean over 15 years or 10 years appropriate, or optimum climate normal? Or is it your own climatology from the model, or is it European Central climatology, or is it observations? So there's all kinds of things. So depending on the climatology that you subtract or the reference period, your anomalies are going to be different. Next. No matter what period we use, the public, do they understand that? Do the public really care? All they need is some guidance or some educated guess for how the average weather will be like in the upcoming weeks as they go on in their lives. Okay, next week, next few days, they know what the temperature is. We are getting it from the weather forecast. But week 3, 4, they need to know right now it's cold. Is it going to continue to be cold like that? So next. So the public understands yesterday's weather, today's weather, tomorrow's weather. They understand snow, rain, no rain, heat wave, cold. They understand the changes from recent current weather. If you are now in a hot spell or in a severe cold, and if it has been for a while, people ask, is this going to continue for a while? Or when is this cold spell going to end? When is this severe hot heat wave is going to turn into different things? So that's the kind of thing people are interested in, not with respect to some climatology, which is by definition is not unique. Next. So the important thing, and this is another quote which I like, the important thing in science is not to obtain so much of new facts, but to discover new ways of thinking about the data that we have already. Okay? Sometimes the answers to the complex problems may be lying right in front of our eyes, and we may be looking at things in a more complicated way. So next. So I am going to be next to presenting results where, based on this model runs that ends up, where the vertical line, blue line is today. Today is the forecast today. It's up to the forecast is made up to 45 days. And then I am going to look at weather average over week 3 and week 4 as a departure from yesterday. Like everybody knows what yesterday's weather was, weather is, or weather was, whether it rained, or whether it is very hot, like 90 plus, like 95. The first question is how long is it going to continue? So people that they can relate to, people that they can make sense of, people that they can remember. Okay? And they don't have to relate it to some 1945 or 1968 or something. This is, yes, you try to express how the week 3 and week 4 weather is going to be as a departure from yesterday's weather. At first I thought as a departure from the previous 7 days, then people said, oh, I don't remember, it was up and down, and I don't know what the average, I cannot compute, I remember yesterday. And the results turned out to be better than if it is just the previous day. You are subtracting climatology anyway for the traditional thing, but all I'm saying is a departure from yesterday. Because yesterday's maps we have all over the globe what yesterday was like in terms of temperature, where it rained, or whatever. So we have those information already. And it is local. Everybody, it may have rained in one place, may not have rained in another, but all the future forecasts are as a departure from yesterday, from the day before that they went. Next. Next. So whatever, this is the prime crux of the results here. This is, I want to concentrate on the right-hand side of the slide. The top one is for temperature, surface temperature, for the globe as a whole. The bottom one is for, again, the temperature globe as a whole. The top one is for week 3 period, and the bottom one is for week 4. This is the climatology. Let me explain this. I did forecasts for the years 1992 to 2010 over a 12-year period. I made forecasts every day for week 3 and week 4 from that day. Okay? And then I computed the departure like what I said from yesterday. and then I compared that with the observation, because for the past data we always have observations we can verify. So, and then I computed the anomaly correlation coefficient. The blue curve, and this is for all throughout the year, from January at the left to December at the bottom for every day. And this is the average over many, many cases, many, many years. And the blue curve is what I showed all along in the beginning. The correlation is between 0 and 0.2. This is the traditional method of how things are. And the red curve is if we do the forecast as a departure from the previous 7 days mean, the future forecast. And the purple color is as a departure from the previous 1 day. It's even better. Okay? The correlation is always above 0.6, which is the reference line or the useful forecast. Anybody knows correlation 1 is good, 0 is bad. Higher between 0 and 1 is better. So there is an annual cycle in there. There are times in which the correlation is better during the middle of summer and between October and November. Somebody said, well, if you are in late summer and you know are heading into fall, everybody knows it's going to be cold heading into spring, so what are you forecasting? I'm going to show you some examples of the spatial map. It's not always one way. Right in the middle of summer, you have a cold period, like what we are recently going through. And right in the middle of winter, you may have a warm spell. It's not always going unilaterally one direction. Otherwise, you don't even need to make a forecast. The forecast is simple. Winter is cold, summer is hot, and that's it. Right? But, yes.
Sorry, can I interrupt for 1 second?
Yeah.
I just have a question. For week 3, for example, where you compute the correlation of the tendency, you do it just every day, right?
Every day, yeah.
And then what you're averaging over is all the days that are in week 3. Is that?
No, for 1 year, for 1 day, like March 31st,
right.
I have 1 week 3 forecast, right?
Right.
For the 1 week period ending that day.
Right.
Okay? With March 31st, it's like a March 25th to 31st, right? And then I do one value that's for March 31st. And then I do it for all years.
That's the difference between March 31st and the previous day?
No. That's the way I showed you in the figure. It is the forecast for week 4 ending March 31st,
right,
computed as an anomaly that departed from 4 weeks before that, whenever the forecast was made, 4 weeks before that. So it's always with respect to the day you make the forecast.
Okay.
Because in real time,
right, I understand.
Yeah, in real time you do not know what week 3, week 4 until it comes. But for past data, we have the observations and we have the forecast. So we can make the forecast and we can verify how the forecast verified. But that is what for 1 year. But then I do it for 79 to 2010,
right.
And it's an average, and that's for you. There is actually 365 points here. Okay, so this is an average over many years. And I will show you how recently this summer forecast, how it's verified. I will show you some maps and I'll give the cool weather and everything and so on if I have time. But anyway, so this correlation now is about 0.7 or 0.8 compared to 0.1 or 0.2. And somebody said, I was just telling that if you are, the seasonal cycle is there, you know, if you are in summer, it's going to stay hot, or if you are going to go through fall, it's going to stay cold. So I subtracted the climatology part of the forecast. In other words, if it's going to get cold, I subtract that part. And if I subtracted that part, all you have in the forecast is purely from the dynamics. And that part is the green one, which does not have the annual cycle in it. And that is still quite high. So no matter which way you cut it, if you assume or look at your forecast this way, you have, instead of 0.1 or 0.2, you have something. But in reality, we will be giving a forecast for the next week 3, week 4, including the climatology, and that one is about 0.7 or 0.8. Next. This is for the near the United States. The region is too small. The earlier one is for globe. The same set of figures you have. Whenever the region is small, the correlations are noisy, but the basic picture still stays the same. low correlation is the traditional way, and then if you look at the forecast out in the out of the box way, as a department, it is quite high. Next, this is for the precipitation. Very clear. Precipitation is one of the hardest things to forecast, and if you look at the precipitation, it's for the globe as a whole, very, very low numbers, around 0.1. Whereas if you look at the departure from yesterday or the day before, the day you make the forecast, it's about 0.8 all through the year. All you are saying is if it rained yesterday and you're making a 3-week forecast from today, if it rained in some place over the northeast, 3 weeks from now, you would say, is it going to rain there again? Or is it going to be no rain at all in that region? Or is it going to be rain about it? That kind of information is what we are correlating. Next.
And that is over the whole globe?
This is over the whole globe.
Okay.
Period. This is over the United States region. Whole globe, I think it is. Okay, can you go back? Go back, please. Hello? Yeah, this is over the whole globe. The next one, next. And this is for the near the United States. Point is, the correlations are quite high compared to the traditional way of doing things. I'm not suggesting or recommending that you don't do the conventional way. Keep doing it. Maybe another 20 years and we will find out where we are. But we cannot wait until that thing and let's have a parallel thing going on at least because we have not seen much progress, significant progress in the conventional way. Next. So this is a typical example for January 2013 for the globe as a whole. This is the verification. This is how, if you make a forecast, today is the forecast you're making. 3 weeks from now, this is for week 4. 4 weeks from now, for the week 4 period, if you subtract what was observed in week 4 minus the day before, and then this is what it should be. This is the verifying anomaly from the globe as a whole. So it has, compared to the day before, whenever the thing, this is going to be 18 degrees colder, this is going to be 15 or 18 degrees warmer, and then over Siberia, there are mass signs of all things. If somebody tells me, if I am over here, Washington, D.C., and there in Canada, it's going to be so cold, whereas in the west coast near Alaska, it's going to be so warm, that information, if they tell me 4 weeks ahead of time, and this is what is forecast. That's the verification. That's, I would say, it's a pretty good comparison for the globe as a whole. Even Australia, for example, there is a little bit warm. There's a warmth over there, cold in the thing. So this is a very good correlation, I would say. Move next. This is for the precipitation over the United States for the different period, 24th of February 2013. This is the verifying anomaly. This is what was observed. This is what it should be. And this was what was forecast. And compared to 4 weeks ago when the forecast was made for this period, and this forecast says there is going to be a lot of rainfall in this region, and that's what was really observed. And there's going to be less precip than now. Looking at it this way, the precipitation anomaly is both positive and negative, and you have that. So this is a very good forecast. This is very good information. That's why I don't need to know exactly it's going to be, but it's going to be a large rain or lack of rain going to be. So this is one is a verification, one is observed.
All right. So those green things there.
Green things is saying that it's going to be between 1 and 2, depending on the color shade, millimeter per day. Per day, for every day, for that period, 7-day period ending there.
More,
because it's
more than it was.
More than what it was the day before when the 4-week forecast was made.
So if you have an awful lot of precip, you're probably going to get less.
No, this one, the forecast is fast. It's going to be more rain.
Either way.
More rain, and this one is going to be less rain than what was there before. So you have both signs. So this is what's saying 4 weeks ahead of time. Okay, next. And somebody may ask, how was it, how did I showed you over the 15-year period? This is for forecasts, for the 4-week forecast ending yesterday. Okay, I do this operationally in my own website. This is not a real-time CPC operation. I do it for fun. I update it every day. So this is 0.6. This is global temperature. This is for the top one is for the global temperature. The bottom one is for the United States, near the United States, for the 2-meter temperature. And the different lines are, this is the week 1P, meaning days 6 to 10. This is the week 2, week 3, and week 4. Bottom line is, they are all above 0.6. The previous codes that I showed you average over many years, because it's average over many years, so a little bit smoother. This is the buck stops here, kind of every day, how the forecast that was made, and I will show you some math. Next. So this is a future forecast. For forecast made yesterday. And that's the closest I can have, because today's forecast I cannot have because it is based on 16 ensemble members, 4 ensemble members on 0Z, 6Z, 12Z, 18Z. Today it's not all complete yet. I will not get all the results until the following day morning. So the latest I can have is forecast made yesterday. And also, luckily, yesterday I have the total analysis. I have what happened really. So compare yesterday's forecast compared to yesterday for the future for week 3 and week 4, week 2, and the days 6 to 10, the entire country is going to be cold by this much in various regions. For example, here in the central part of the country, it's going to be as much as 18 to 21 degrees below, but generally cold everywhere, slight warmth in the west coast, but in week 6 to 10 days, it's going to be slightly warmer, but generally everywhere cold. This is the forecast for weeks 3 and 4 based on forecast yesterday. Which kind of makes sense in a way because we are heading into September, it's going to be cold anyway. But as I said from the global map, we generally had a cool winter anyway. I looked at maps which were made in July, and half the country will be warm and half the country will be cold. And it's verified accordingly because it's not always of one sign. That you have, yes.
So can you think of the reason this works so much better than an anomaly correlation is because you're somehow taking into account the actual state of the system when you start the forecast?
That's right. The reason somebody asked me that question, let me explain. If you subtract a climatology from this model, from this observed system forecast, you are pretty much contaminating the signal because your climatology is made up of information from El Nino conditions, La Nina conditions, the neutral thing, everything you are subtracting from. And probably, as you said, depends on what climatology you subtract, kind of a thing. And you are, this year, this may be completely, for example, let's say this is an El Nino kind of a year. It is early El Nino kind of a year. When you have to go back, and what you are subtracting from is the initial condition pretty much. And what is evolving is the current climate evolving from now. So there is no contamination from the other parts of the climate system, which you are subtracting from either one of them anyway. So that is the best explanation I came up with as to why doing it this way gives you a better. And one other advantage of this is, as I will tell you at the end, if somebody is using hindcast, for example, they are using a climatology of forecast, how the forecasts were 30, 40 years and trying to do some verification compared to hindcast. You don't need to do any hindcast for this. Because all I need is that you can continuously keep making model changes. And all you need is the latest 40 days of data. There is no reference to any past data at all. So as you can keep on making model changes because any place in any center, they will always be making model changes because a new physics parameterization, a new addition of numerical scheme or whatever. So anyway, that is why I see that there is such a difference between looking at this way. All you need is a different paradigm shift, a thinking as to how we want to interpret. Anyway, so week 3 and week 4, how we want to give the forecast out to people next. Next. So in summary, in spite of the enormous progress that has been made in modeling, physical parameterization, data assimilation that led to significant advances in weather prediction out in the next few days, real progress in the extended range, a few weeks to a season remain very slow. If we do not have an open mind and we are not willing to think differently about how we make and verify the forecast, in particular in the elusive week 3 to 4 time scale, then 15, 20 years from now, I'm not sure whether we will be in a better place than we are now, because that's how it has been for the past 20 years, 20, 30 years. And I'm not suggesting that you don't approach that way. Continue to do that. There's a lot of money spent on now intra-seasonal prediction. So much money is being spent on this, on week 3 and week 4 and NJO and so on. Next. So but if you are willing to experiment and think outside the box and produce forecasts, or at least some sort of guidance to people for week 3 and 4 along the lines presented here, even on an experimental basis, don't make this official. You put it out. This is week 3 and 4. This is what we think. Based on, this is not voodoo magic. This is based on models, the same models that you are using. And you are telling it as a reference from yesterday. And I was told a few went and were saying, oh, this is something utility companies will simply law, this kind of a thing. But as scientists, we don't think of it that way because we have always been constrained to think in the long straight line and don't change the rule. I mean, in private industry, they give people to think differently than the conventional thing. Anyway, and so this study offers a new proposal to make and evaluate forecasts in the 3 to 4 range, and let the public be the judge of whether these forecasts are of any value to them. If nobody comes and says, we don't care, we just only need with respect to climatology, which has no skill anyway, go ahead, we may make those forecasts, we know how much skill it has. And there is no need for any expensive long-term hindcasts or delays in implementing model improvements. You can continuously keep all you need is the latest data. Next. I am working on updating on a real-time basis and put these forecasts and the skill scores, how the skill scores have been this past summer, this past winter. Continuously, I've been doing that in my website. And there's a better website under construction because I do this for fun. 1997, I suggested to CPC that CPC should issue National Hurricane Outlook. And somebody said, no, only National Hurricane Center. That's the national. I said, no, National Hurricane Center issues hurricane forecast after the hurricane is formed for the next few days. I'm talking about a seasonal hurricane outlook. I came up with a method, and they said this can be implemented. They said, no, they are not interested. Finally, it was implemented. And now, Bill Gray was not, at the time, Bill Gray was the only one who was doing it. And I came to the conclusion after looking at 30, 40 years of reanalysis data, which had just become available, and I looked at the relations between weak hurricane activity decades and strong hurricane activity decades, and then, and then I said there is some signal in, and we can say ahead of time. And I went backwards and did the forecast, and finally it was again came from top down. They said, okay, let's make this forecast. So I'm not expecting something similar because this is different than, because that was more along the conventional way, what I proposed. Only thing is I said, we can make this in hurricane outlook. Why would only Bill Gray do the outlook? We can do it. No, a government can do it and we can give it for free to the people. Now it's one of the hottest products by thing. I got bored with that and I left the team and this is my new point. So anyway, so Yeah, that's why if anybody wants to go look at the website and look at the forecast, I'm trying to keep it as current as possible because this is not a highly operational thing. So whenever the computer is up, especially now there's a lot of changes with the gyre and the tide going up and down. So I physically have to, if they are running fine, I don't need to interfere at all, and all the forecast will be in real time. So next. So I have a preliminary write-up, and I want to thank Zhao for encouraging me to come and give a seminar here. I wish other people had listened, but I don't know whether people have. You have the recorded version of it.
Yes, we have the recorded version.
And I want to thank John Chettal for inviting me to come and give a talk. And a manuscript, I'm very slow in writing manuscripts. I get an idea, I get excited, get the results, and move on to the next thing. That's my weakness. So anyway, so we have a preliminary write-up in Zhao's digest from last year. Next.
What's the CDPW?
Where is that?
CDPW.
What is the diagnostic?
Climate Diagnostics Prediction Workshop.
Okay.
Climate Diagnostics Prediction Workshop. Manuscript is under preparation, and that's the end.
Okay.
Thanks for listening.
So this is a lot to chew on. It's very stimulating. So let's try, John, just as a question, has anybody, are you able to see if anybody submitted a question through the chat?
Yes, let me, hold on just a second. I can, let's see. We got questions. There's a lot of questions, but I believe they're related to the earlier difficulties we're having. If anyone has a question that we haven't addressed, go ahead and resend it.
Okay, so pipe in if somebody does, John. You pick one up. But I have a question. So it's basically you're picking up some inherent skill that was not evident using the conventional metric. Is that what essentially what you've done here?
It's all coming from the same model, what we use today.
Right. Absolutely,
yeah.
right.
It is a definition.
The conventional metric did not show
exactly
the skill.
Right.
This appears to do so.
Exactly. And as David Strauss's question, why is the skill appears to be high here versus rather poor skill in the conventional way? And the answer I gave you was that what I said before, which is like if you are subtracting a climatology which is contaminated with the information, climate information from stuff which is irrelevant to what's happening now, right now, which is completely absorbed in the initial conditions, is completely absorbed. Because not only that, the forecast, if there is any inherent model bias or weakness in certain areas in the model, this by subtracting that will be there in the analysis, that will be there in the forecast, it has subtracted them out anyway. Whereas you do not know what, and it is specific for the sun. We know models have different biases during winter and summer and so on, and they have different biases, behavioral differences during El Nino, La Nina, neutral, that kind of a thing. And in the context of global warming, we don't even know how our models are capable of doing this compared to a reverse trend period anyway, something like that. So anyway, I think that's because as I said, this is fairly simple, straightforward thing. And I have, okay, can you move forward, please?
John, can you advance the slide?
Can you advance the slide, please?
Hold on a second. Okay. All right. Did that do it?
Yes. No, you didn't. You take the stuff away from the bottom. I think that seems to be.
If you click the mouse, John, you'll
click the mouse.
PowerPoint. Okay, now navigate.
Okay, this is the website. This is stuff updated as of this morning. If you don't remember the website thing, just Google CPC products and my first name, Muthu, and it will take you to this website. And this is from, as I said, I'm not a technician. I'm just a scientist. So I just learn how to do a simple website, and I put all the maps, and you can say forecast made. This is not clickable, so move on. And then next. Oh, that's it. Okay.
So not just a follow-up question. So can one apply the same technique to shorter range forecasts?
There is no need, because shorter range forecast up to 7, 8 days or something, because we know exactly we are doing well in that anyway. It is we are doing this only in time scales where we have no skill by the conventional way. Tomorrow's forecast is, as I showed you in the thing, it was day 1, 2, 3, 4. I would say even for week 2 we can, but they are claiming that they are trying to have better skills. But week 2 by this method is even have better skill by the conventional method. That's what I would say.
But in terms of having a continuous metric across from shorter to longer,
I don't know if we can do that. It's like one shoe fitting everything. I don't think it will work. It has not worked in any social setup and outside. I don't think it will work now, because the people would want to tomorrow, is it going to be 80 degrees, 85, 90, 95, that kind of a thing. We wish we can say that for week 3 and 4, but we know that we cannot say beyond 7, 8 days or even 6, 7 days what exactly the weather forecast is for a given day. That's why we average stuff and try to say, because tomorrow we know there's a cold front coming through, we know for sure. But in week 3 and 4, we know a cold front might come through and it will be cold, but we do not know exactly which day it's coming through, but definitely week 3 is coming through. From the hot weather, it's going to give us a break. So that is why we average things. But then I'm saying, do not use this as the compute the anomaly with respect to some 20, 30 year climatology, 50 year climatology, but use it like based on what's happening now. Yeah. Because if a cold front is going to come through, that is probably out there in the Pacific Northwest somewhere, and there is, remember, this is neither weather nor climate. There is some initial condition impact here. There is also a boundary condition impact if there is a pre-El Nino kind of condition. It's built in both. That is why you need a new. I don't believe that.
But in the same token, your logic that you presented for how people think about this for week 3 to 4, I could extend the same logic to a day 5 forecast. I could say, well, I know what the weather was yesterday, and in 5 days, I'd like to know, is it going to be, warmer, colder, wetter, drier?
You can, but because our weather forecast models are also very good, you have both information. I'm not saying you don't need to, but in terms of correlation, if you want to use correlation as a skill metric, compare it to that way versus this way, I think the skill is about the same. But technically, this is not limited to week 3 or week 4. In fact, I wanted to combine week 3 and week, because there is some initiative to combine week 3 and week 4. And then I said, well, I can do week 5 and 6 technically, but then that interferes in the monthly forecast. And monthly forecast, the skill is not that great. It's very, very, very poor also. But we don't talk about that because seasonal forecast, we have some skill. Maybe monthly is even worse than seasonal.
Let me, John, just checking in with you. Did anyone pick up a question that
sure.
We can?
First, John Ice wanted to pass on that he thought it was excellent work, so he just wanted to make sure that got out there. And then there's a gentleman by the name of Subhadip Halder, and he wants to ask a clarifying question. If you would like to go ahead and talk, I have you unmuted.
Okay, go ahead.
Yeah, I'd like to ask, I didn't understand how you calculated the anomalies and then then you showed the correlation. Would you please explain the technique once more?
Okay, I will make it very simple again. If you are making the forecast today for week 3 and week 4, I subtracted the model forecast, the total field week 3 for week 3 and week 4, that minus today or yesterday's weather mean. So this is an anomaly with respect to what was observed yesterday.
Okay.
So that is the I don't want to call it an anomaly because usually anomaly, the term is with respect to climatology. I want to call this as a tendency or as a departure, whatever you call that. Is that clear?
Okay, and how do you do it for the 7-day mean?
I still use it, I average over the 7 days, week 3 and week 4, I still subtract it from yesterday, 1 day mean.
Okay.
Because I have tried with respect to the past 7 days, but the results are better if it is with respect to only 1 day, mainly because it also works out this way. People say that I remember yesterday what the weather was like. I don't remember what the average weather was like over the whole week. Now, some days may be cold, hot, warm, especially winter time, spring and fall, where there is so much. You always remember yesterday's weather in your skin, whether you wore a jacket, whether it was freezing ice, snow, whatever. You always remember yesterday's weather.
Okay.
This is with or the heavy rain. If it's 90-degree plus, now you tell it as a departure for week 3 and week 4. I'm not saying on a given day. I'm saying on average over week 3. That's what I'm saying.
Okay. Thank you.
Thank you.
And that's all the questions I have at this point.
Okay, we've got one in the room.
Yes,
Dennis, you want to?
Yeah, I'm still trying to understand the method somewhat. You're saying you're making the forecast, let's say a model such as the GFS model, and you're making that forecast out through 3 weeks or 4 weeks? You're just continually running that model?
every day, yes.
For every day, for how long? For how far out are you?
Well, now this is what I am doing is not GFS, it's only CFS. GFS right now runs only up to 14 days.
Okay, so what model?
This is the CFS. This is the climate forecast system. This is the coupled atmosphere model. This is the CFS version 2. This is what we use. This model is actually run up to 9 months. Not just, I'm just speaking of week 3 and week 4 because that is where nobody is addressing it. And 9 months, the model for, remember there are 16 ensemble members. They run the model out to 9 months, 16 times a day, every day. And I average all the runs, the 16 ensemble members, all the forecasts made by 16 times for week 3 and week 4, average all the forecasts. And that I call is the why ensemble numbers, because the more ensemble numbers, the better.
So you're basically taking an average of 16 ensembles for a 7-day period.
Week 3, week 4,
for each week.
Right.
Each week.
Yeah.
And so just by making a delta or a difference between that and what the field was yesterday, versus taking that average field and comparing it to climatology.
Right.
You're saying that you're seeing.
Not seeing, what I am calculating and I'm obtaining. Yes.
You're obtaining better correlation.
Yes.
But the forecast is the same.
Forecast is the same.
So
Nobody's comparing.
So
nobody's comparing the, oh, by the way, I have in all those maps I showed you, I compared the total field itself. Forget about the anomaly, forget about the departure. I compared the total field itself. In meteorology, nobody does that because those correlations are always 0.95 and 1. You know why? Because it is dominated by the full field, like the, if you complete the correlation over the whole globe, for example, for temperature, the poles are always colder any time of the year. The equator is always warm any time of the year. So those large-scale features dominate the correlation, and then even for a bad forecast by which I calculated my way, even for that the correlation is still like, I have all those numbers if you look at the map.
I mean, I think I understand. I hate to be a naysayer, but
Please do, because I want somebody to challenge me all the time. Because I want to know where I'm doing wrong.
Okay, we live in the East Coast and Mid-Atlantic of the United States. Okay,
Right.
The last week has been cooler than normal.
Right.
Okay, so let's say 4 weeks from now, I want to know, is it going to be like this? Is it going to be cooler than normal still by maybe 5 degrees? Or is it going to be about normal for that time of the year or warmer than normal for that time of the year?
I gave you a forecast.
In the eastern United States. How is this going to actually make a difference in how that verifies. You know, if you told me you improved the model so that the model is 10% more likely, let's say, to pick up that it's going to be warmer than average 4 weeks from now on the east coast of the United States. Let's say you told me that you can do it, and that the model made some sort of improvement in that way. But what you're telling me is that it's sort of like you're looking at it through a different pair of glasses.
That is what I want you to do. That's exactly what I'm asking you to do.
Okay,
don't use the same glass.
Okay, but is that really a real improvement?
It's a skill is there already. He's just revealed it. That's all.
It's like, exactly. It's not, nothing is new. It's all coming from the same model. You just, it is like saying, it's $1 million, you can be happy or not. You can be happy or sad if you have the reference. If you are among poor people, you are a rich man. If you are among millionaires, you are a poor man, maybe. So all I'm saying is that it's from the what kind of a reference are you talking about?
Right.
And I already talked about contamination by subtracting from climatology and something which people look in terms of from people. See, when somebody says it's from a climatology, do people understand what a climatology is? Your 50-year climatology versus a 30-year climatology, average over what? Just over last few years? Average over 50 years? Each time you subtract a different climatology, different reference period, you get a different anomaly. And an anomaly of 2 degrees over the East Coast, for example, I will make it 5 degrees by subtracting a different climatology. So it is arbitrary anyway, right?
Okay, so we're going to have to end the forum for today. I want to thank Dr. Chelliah immensely for the presentation. It was wonderful, very stimulating, and for tolerating the sort of technical difficulties, as well as our audience. Apologize again for that. However, the entire recorded presentation will be uploaded to the website, so you can listen again at your leisure and share it, the slides, etc., with your colleagues.
If there are any questions for the audience who were not able to ask the question or have to leave because of time considerations or anything, if your colleagues had any questions, please email me with any of your questions, listen to the presentation, and then anything, challenge me, as I said. I look forward to those difficult situations because it makes me think twice.
Right.
Thank you.
Very good. Thank you so much, and we'll be signing off. Have a good evening, everyone.
Bye-bye.
Bye-bye.
Thank you.